Landslides are the natural hazards which can damage, destroy the ecosystem, harm agriculture, damage building infrastructure, lead to economic losses, deaths, social distribution, and can lead to other hazards as well. Thousands of small and medium-sized ground movement follow earthquake or heavy rainfall. It's mainly due to the climate change, population growth, and unplanned urbanization in unstable mountain area. The early landslide detection is very useful for quick response and management of consequences. And also the accurate detection of landslide can help to create the accurate landslide susceptibility modeling and risk management. So in this video, I am going to show you how to detect the landslide inventories using Sentinel-2 dataset. In this video, I am going to build the deep learning neural network for the accurate landslide inventory detection. So let's get started. For this particular task, I'm going to use the Google Colab since it gives us the free GPU so that I can train my model. So here is my preliminary code. And then for this particular task, I'm going to use the Landslide4Sense dataset. Thank you very much for providing us the training, validation, and test dataset. Right now, I'm going to use training and validation dataset only because test dataset is not released yet. And then if you see the example, so they will provide us the data with RGB image, I mean the Sentinel-2 imagery from band 1 to 12, and then slope dataset from LS pulsar band 13, and then DEM for band 14. And then if we try to visualize it, so it will be look like this. So it's the RGB image, and this is slope and DEM, and then the max level for the corresponding image. So to do that, actually I already downloaded this data with my credential. First of all, you need to log in, and then you can easily download the dataset. And I downloaded my dataset and already uploaded it into the Google Drive. So the all the dataset inside data folder, and then I have the image data like this separately, which is YATS5 format, and then also the corresponding max data inside the max folder like this, max 1, max 2. And then also I downloaded the validation dataset, but for the validation dataset actually they will provide only the image, and then we have to create the max for each image, because I think I started this building this pipeline on uh, June 15, I think. By that time they did not have the max dataset. I think they already uploaded. Now you can validate your model as well with this validation data. Okay, so for this purpose, actually I created one GitHub repository called Landslide4Sense solution. So all the code will be available here. I'll update you about this repo, and I'll provide this link in the video description. Okay, so let's get started. So first thing is we have to install the required library and set up the basic things. So here I'm going to use the TensorFlow latest version, and then Matplotlib for the visualization of image. So first thing is you need to install these two libraries, but for me I already installed, so no need to run this shell. So I'm going to run from third shell. So I'm just importing the required libraries, pandas, numpy, and this s5py library is very useful for learning, I mean reading the .s5 format. And then also Matplotlib and TensorFlow. And this globe is for iterating the folder and then getting the corresponding image. So first thing is we have to link our Google Drive. So I'm going to run this cell and then it will ask for the verification, and simply I click here and then I allow the my drive. All right, now I have to set up the child directory so that I can use the relative path. So I'm just running this cell. Okay, so first of all, I want to test the data set. So I took the random paths, single image, and I think paths for the same max. So it's inside data image and image 2000 image, and then uh, number is 2000. So I'm just simply running this. And then if I run this cell, so what it will do is what I'm doing here is I am reading this S5 format file using S5 Py library, and then I simply first list out the keys, and then I found there is only one key, which is img. You can see it here. So I'm just getting this img img key, and then I'm just simply printing out my data set, and then I'm just visualizing my data plt.imso. And then here actually the our data shape is 128, 128 and 14. So but for the visualization with matplotlib format, so I need only the uh, three keys. So for that actually what I did is I did from 3, which is the red channel, and then red, green, blue in -1 means negative indexing. And also if you want to create the ndvi from this image, so you have to uncomment this, and then here what I am doing is data red is of course our data set is 128, 128, 14, and then our fourth band, which means index it is the third one is the uh, our red band, and then second one is green, and then first one is blue. So I'm just getting the NIR as well, and then I'm just calculating ndvi formula is NIR minus red by divide by NIR plus red. So I'm just using numpy formula to calculate the ndvi, and then if I visualize the ndvi, so our product will look like this. So this is the ndvi of corresponding image. And if we try to visualize the max similarly, so max will be look like okay, it's running. Okay, it will be look like this. So this means this in this particular area, this yellow color, the landslide occur. So okay, so that's all about testing. So I'm going to use all the data set, which is for me my train path is data slash img, and then all the s5 directories, s5 files, and then also for the max I have all the s5 inside max folder. And then here I'm just creating the my train xx and train yy uh, zero matrix, I mean zero numpy array with size of 3799 and 128 by 128, and then I am going to use the 6 band for this particular task. And then of course the train yy will be same size with max, it's just 1. And this is the number of images that are available inside this folder. So if I run this cell, so it will assign the 0 values to train xx and train yy, uh, my this numpy array. And then here I am getting the all train and all max, I just sorted the these values, and then simply now I can check whether I am running on GPU or not, because it's a loss of computation. So I just verify, and now I am running on GPU. Okay, so here in this for loop, what I did is actually I did the similar thing as we did in here. So this is for only one image, but now I am iterating the same function with all the images. That means I am just running, I'm using this enumerator so that I can use this index, and then also I zip all the train and max values inside img and max. So if I list out the keys, it will be image for the image and then max for the max. And then here actually I am assigning 0 value for the non values, and this is I'm calculating mid RGB, slope and elevation, just to normalize the data. And then here I'm similarly calculating the NDVI, and then I'm pushing it to the final array train XX. So it's the index, and then my first element of this train XX will be the red channel, and then second one will be green, and then third one will be blue, and then fourth one will be the NDVI image, and fifth one will be the slope and then elevation. You might wonder why I divide it by mid RGB and then subtract by 1. So it's just for the normalization of data set. So what it will do is it will provide all the values within the -1 to 1 range. So I just want to normalize all the values between -1 to 1, because previously if we check the max and mean value of this image, so it's around, I think, 3 or 4, even greater than 4 as well. So I just trying to normalize all the image values within -1 to 1. That's why I'm just doing this. So if I run this cell, so what it will do is it will iterate over all the files, I mean the image and marks, and then it will assign values to the first channel will be red, green, blue, NDVI, slope and elevation, and then it will just assign values to train XX, and similarly for train YY as well. So I'm just getting the max, and then just assigning this max to the first channel. So I'll stop this video and then uh, resume it after running this cell. All right, now the previous process is completed. So I'm going to run this cell to test whether my all the data are between -1 and 1. Okay, so my train XX minimum value is -1 and train XX maximum value is 1, which is great. So which is actually what I want. And then train YY actual my max is 0 and 1. I think there is no value between these two numbers. So here actually I'm going to write the another costume loss function, which is dice loss. Its formula is explained here. So the dice loss is, it means the 2 into intersection area divided by total area. Total area is the total area from prediction and total area from ground truth. So I think instead of using this loss function, there are really lot of type of loss functions. One of which doing great is dice loss. Actually there is binary cross entropy function as well. Also you can try with the IOU loss function as well. So for me I'm just going to try dice loss function. And to visualize this result, I use matplotlib. So if I try to visualize the results, so this is my RGB image, and this is the NDVI image, slope, elevation, and this is my max. That means this in the yellow part, the landslide happened. these are the inventories. Okay, so now I'm going to split the data set for validation because I don't have the validation data set marks value. So I'm simply using this Escalon model to validate split my data. Actually, if you don't have this Escalon library, so maybe you need to run the pip install scikit-learn. So I'm just running it and then splitting the data set with 20% of my validation data set, and then I try to shuffle it. Okay, if I try to visualize again my train data set, so I think some error happened here. So okay, it's here. Okay, it will look like this. So this is my validation data set with image number of 1545. Okay, if I try to check the shape, so shape is of course my trend data is the 80% data set, so it's 3039 data set, and then I am using 6 bands, and then for the max it's only 1 band. And now to train my model, actually I want to release some memory so that I can delete this train xx and train yy variable, because I already split my data set. I can use this variable now. So I just release the memory, and then if I try again, so it will my data set is look like this, which is good. All right, now it's time to write the UNet model. So for the UNet model, I'm just using the basic net, so which is with the some few convolution 2D network, and then also max pooling layer. So here actually I have this utils.py file as well for the accuracy, for determining the accuracy metrics. So to know the precision, recall and F1 score, so I write this utils.py file and then upload it here. So this is just for the accuracy, and this is the basic model. So here this model ends here, and then after that what I did is I compiled this model with the optimizer is Adam optimizer with the default learning rate, and then previously I tried it with the dice loss function, but the accuracy was around, I think the F1 score is around 0.589, that means only the 58%. So this time I'm going to use the binary cross entropy loss function, and then matrix is F1 score, precision M and recall M, and then if I run it, so it will give us the UNet model. And here in this particular section, what I did is I assigned this UNet model with the model variable with my image size is 128 with 6 band, and then I have this check pointer here. So what it will do is, it is the callback function. What it will do is, if our model is based in next report, so it will just replace the best model. So what it will monitor is, it will monitor the F1 score of our validation data set. So if the F1 score is increased in next report, so it will replace the best model and save it to the location of our Google Drive. But if it did not improve, then it will use the previous best model. And then I assign this mode as max. That means whether whenever our F1 score is increased, then it will simply replace the best model variable. And here in the history, actually what I did is I am fitting this model with the X-train and Y-train dataset with batch size of 16, and I'm running this model for only 100 reports, And then our validation data set is x valid and y valid, which I split using scikit-learn library. And then callback function is the callback parameter. And of course, if you want to stop the model, continuously monitor and stop the model if your best score is not updating within 10%, I mean 10 epochs, so you can use early stopping this callback function as well. You have to simply uncomment these things, but for now I think it's okay with checkpointer only. So I'm going to run this function and then see how much accuracy will I get by replacing this loss function. So it's running, so I'll just pause the video and then resume whenever it finishes loading. All right, now processing from previous cell is finished. So if I run this cell, so I can see my F1 score is around 70%, 70.82, so which is really nice. So now I just want to see the graph, I mean the loss function or precision am and recall am function. So here is my model loss function epoch, loss function within each epoch. So my model is trained for 100 epochs, and then this is for the precision, and this is for recall, and this is for F1 score. And now if I try to predict my landslide patches, so I set off the threshold value at zero point 0.5, and then now using model.predict I can predict the x valid my array. So if I run it, and then in the second cell what I'm doing is I'm doing using this prediction image. If the value is greater than zero point 0.5, then I'm storing it as a 1, otherwise store it as a 0. So I'm just making the binary classification using these predictions. And here if I run this cell, so I can get the my prediction and actual level and then the training image. So maybe in this image it's not available, so if I change it to 155, so it's here. So this is my label, actual label, and this is my prediction. So both looks a little bit similar. I mean the accuracy F1 score is up to 70%, so it's really a good accuracy for getting start. And if you want to fine tune this model, so you might need to change the learning rate and then also other parameters, and also try to write the custom loss functions. So that will of course it will increase the accuracy. And also you can try to train your model for the different bands. All right, now I want to test my model for the validation dataset. So for the validation dataset also, I have 245 set of paths using our scikit-learn split function. And now I defined the zero values with val xx. And then now what I'm doing is I'm iterating all the image and then basically doing the same thing with train xx. So here I am just normalizing the data set using mid values, and then I am storing all the values with val xx. Variable name is val xx. So if I run it, so it will run through all the image and then it will create the val xx. So I'm going to predict this validation val xx value using zero point 0.5 threshold value, and then I'm simply trying to predict all the imagery. Okay, now it give me the array shape of 245, uh, 128, 128, and 1. This is the binary class image max prediction. So now if I try to visualize it, so we can visualize like this. So okay, I think I don't need third axis, and then maybe this is the second, this is also second, and this is 2. Okay, if I try to run it, so for the 150 image, looks like this image does not have any landslide occurrence. And if I try for 155, it's also same, maybe 167. Okay. All right, so we got the landslide area. Most of the image, I think, in the validation data set, we don't have any landslide. That's why we are not getting we are getting prediction of fully blank. That means there is no landslide inventory. But with this 167 imagery, we got it has some, I think, landslide. So we can see it in the training image, I mean, validation image as well. And now the last process is to save it this prediction back into the .s5 format. So for writing the file format, I am going to use this I mean this location right directory, and then I'm going to iterate it over the max name. And then now what it will do is it will write the .s5 file inside this location. So if I run it, so I can get the max images within this directory. So okay, let me run it first. All right, now writing is finished. So if I check inside the validation, so here I mention the validation path will be validation slash max. So I tried masking multiple times, so maybe this folder you can ignore it. And then this is the writing directory. So if I see it here, we can see we get the max for all the validation data sets. So in this way uh, you can write the s5 file, and then if you are competitor in this challenge, so you can simply zip this directory and then submit it to Landslide4Sense challenge. So right now I am just getting 0.70% accuracy without doing any fine tuning. But if you are the deep learning specialist, or if you know the better way, of course you can improve the uh, model accuracy. And then of course at the end, I think someone will write the really nice function to fine tune this model, and then maybe they can use the different model, so which might be very useful for this task. So I'll also update about this in the future, but for now this is simply the pipeline of how to use the landslide for sense dataset, and how to build your model, and how to predict the imagery of landslide inventory. So that's all about this video. I hope you guys like this video. If you like this, please hit the like button and share to your community. Thanks for watching. And of course, if you know any good fine tuning things or any good model, please share with me in the comment section. I love to hear from you, and thank you for watching. See you in next video.